So today we're going to be going into Unit 2. It's actually a really short unit with only 5 lessons. And after you've been through your web quest, you should already have some background information of what simple machines are. So we're going to go fairly quick on the topic. Okay, so lesson 1 is on simple machines. So basically what a machine is any devices that actually help us perform a certain task. And there are 5 main functions of why we would develop some sort of machine. Okay, the one is to change energy. So for examples, if we have, say, Niagara Falls and we're looking at hydroelectrical generators, we're using falling water, which is a kinetic energy, and is turning into an electrical energy. So first function of any machines that could be created is we're changing form of energy. Okay, second types of function are transferring forces. So a car transmission will transfer the force from one motors to the wheels. So your motors are generating some sort of movement thing, and we're transferring that force into wheels. Okay, so the third type is to change the directions of the force. For examples, flagpoles. So what happened is when we pull the rope downwards, we're actually attaching it to the pulleys that is to raise the flag up to the top, right? So we're changing the directions. Okay. And number 4 is the change of magnitude. Okay, magnitude means how strong the force would be, and it's actually very, very easy if you and also very useful for you. Okay, like say for example, systems of pulleys will make it easier to hoist a car and engine out of the car, right? So what happened is we have the upward pulling force. We're later on going to calculate, with different numbers of upward strings, we can actually make the actual force of pulling it a lot lesser. And same idea goes with, I don't know if you've ever heard of anything like this, but like if you ever have a car stuck in the mud or something like that, if you are trying to pull it out this way, the amount of force is whatever true force you're putting on. But if you actually change and actually make 2 ropes that are going this way, and then you pull up on a certain direction, you actually have 2 ropes that are helping to actually cause the force required to be a lot lesser. And finally, the last type is called the change of distance or the speed. Okay, so say bicycle, you have your rear wheel of the bike. It would actually turn further and faster if you attach it to a pedal. So in the pedal, you don't have to pedal really far, but because of the rear of the wheels and axle, you're able to actually use those advantages to help you move a way further distance than what your pedaling distance is when you're stepping on the pedals. And there's 2 basic types of machine. Okay, one is a lever and one is an inclined plane. So lever, it's anything that kind of have a turning point. For example, if I have something here and say a catapult or something, a catapult, well, you put a stone on one end and you press down on one, that's a lever. Okay, and important thing is that lever always would have this point that's called the fulcrum, basically the turning or pivoting point. Okay, and that's how you recognize things that belong to a lever family. There's a point that we're changing the direction and rotating around it. Okay, an inclined plane, as it is saying, it has kind of like a general shape of a triangle. Okay, and that's an inclined plane. And the 2 main families have kind of relatives, right? So within the lever family, we have obviously the lever. Okay, so the first one is the lever. Pulleys also belongs to the lever family. As I said, there is a turning point. So there is your turning or the fulcrum, the turning point. Wheel and axles have the turning points. Okay, and then kind of in general, you would have an inclined plane. An inclined plane is the slope. So do you see a wedge is also an example of an inclined plane family. Jack screw. The reason why they say a screw is actually an inclined plane family. I know it has a fulcrum too, but the key thing is the slope. If you roll this up, do you see how your screwdriver will actually, a lovely drawing here, like it's actually an inclined plane that is kind of roll in above and causing it, like, so this is the part of the inclined plane. Okay, now we're focusing on the lever. You should have already read up how many. If I ask you how many types of levers there are, you should be able to tell me there's actually type 1, 2, and 3. Okay, so what a simple machine is, it actually will change the amount of force you exert in order to move an object. A lever has a rigid bar that rotate. Remember how I said the key thing is the rotating, which is your fulcrum? I usually use the symbol of circle just to show that that's a turning point. Okay, so you need to know this term that's called the fulcrum, which is the rotating point of the system. And you also need to understand what different symbols are, because tomorrow we're gonna go to lesson 3, we're actually gonna go on and do calculations. Okay, effort force, Fe, it's basically the users, right? The user would push down or pull upwards, or whatever force we apply for it using our hand. Okay, the load force is the force that is exerted by the load. Say, for example, I'm trying to lift a rock. Okay, so this is the rock, that's the load. And then the fulcrum is the turning point. And then the effort is me using my hand or pushing it down or something like that. And that's the effort force. Okay, and then other definitions include the effort arm. Oops, I meant to use a highlighter. The effort arm, so how long from the effort to the fulcrum. Like, do you see the turning point? So fulcrum measuring to the effort, this is called the distance of the effort. Okay, and they always measure from the fulcrum to the effort force, so your hand or whatever the tools you use to push down. Okay, the load arm, on the other hand, I think fairly straightforward enough, is measured from the fulcrum to the load force. Okay, so the fulcrum is the turning point, and where the load is, this is the distance of the load. Okay, D for distance, force for F. Okay, 3 kinds. Class 1 of a lever, you would have the fulcrum is in the middle. Okay, so if you have your load of your fulcrum and your effort, okay, I'm just using symbol LOE. Okay, key thing is it could be backwards, right? You could have EOL as long as the fulcrum is in the middle. Okay, an example for that is a teeter-totter. Okay, class 2 is when the load is in the middle. Okay, so if load is in the middle, either the fulcrum is here, as the key thing is load is in the middle. Okay, so an example for that is a wheelbarrow. Okay, your wheelbarrow, you know how your barrel, I'm going to draw, these are rocks. And then your arm is here holding, so this is you. Oh, so this is your effort. Do you see your load is here? But the pivoting point is over here on the side, right? So when you lift it up and then you start pushing it. So a wheelbarrow is an example. So the key thing to classify, so on the test, I'm going to give you example of whatever tools it is, and I'm saying please classify it. The key thing is recognize what's in the middle. Okay, so I always draw my little picture like that. Okay, so the last one is class 3. Class 3 is the force, the load. Okay, so what happened is the effort force. So they tell you the applied force is between the load and the fulcrum. Okay, so the fulcrum, the effort force, and the load. Okay, can you think of an example of something that your hand is in the middle, but your load is on one side, and then the pivoting point, the fulcrum, is on the other side? Okay, an example is a tongue. Okay, so like think of you picking up a sugar. Okay, I'm going to try to draw. Okay, so if this is a tongue, do you see how your cube, your sugar is here? So this is my load. But your finger is pushing down like this and your thumb is on the other hand, I'm so sorry. You know I'm a wonderful artist. Okay, but then the pivoting point, the fulcrum, is right here. This is where the fulcrum is, right? So I got my fulcrum, my effort, meaning my hand, and then my load. Do you see how the effort is in the middle, making it a class 3?